The purpose of today's activity is to verify Newton's second law. And you're going to use a pulley system, much like you saw on the quiz today, in order to verify Newton's second law. It's going to be set up essentially like this, although this diagram is a bit of a simplification. You're going to have two masses. One of those masses that we're going to actually call M2 is going to be on a cart. That cart is going to be on a track. You can see the tracks up at the front of the room right now. Some of them are the wooden tracks, some of them are the metal tracks, and you guys know the deal with that, right? Just make sure you pick the right cart for the track. So put a cart on a track, and then maybe you put a mass on that cart as well. You're going to have to measure the mass of that cart/track combination. So when I say M2, that's going to include the mass of the cart itself, not the track, but the cart and then whatever mass you put on top of it. Now, that mass 2, that cart/mass combination, is going to be attached to a string, which is going to go over a pulley, which is going to be attached to the edge of a desk, okay, which is going to be attached to another mass that we're going to call mass 1. You need to record the values of both of those masses, mass 1 and mass 2 in kilograms. There will be a force of gravity pulling down on M1, but that's not going to be data. That's going to be that's ultimately going to be analysis, right? Because that involves a calculation. So far, the only data we have so far is the value of mass 1, and that's just literally a mass hanging down off of the string, and the value of mass 2, which is a mass from a mass set in addition to the cart that you're putting the mass set on. You're also going to have that track, but we don't need the mass of the track. All right. Now, we're going to put a motion sensor back at this end. And of course, you're going to connect that motion sensor via Bluetooth. You're going to connect that motion sensor to the AirLink apparatus. And then you're going to connect the AirLink apparatus via Bluetooth to your phone, like we have on a number of occasions already. And then you're going to, when you go into the app, the SparkView app, where you normally select position. You guys know the deal, right? You normally select position. This time you're going to select velocity so that we get data not for time and position, but so that we get data for time and velocity. Now, you're going to have lots of it. Okay, I've only got 3 rows listed here, but you're going to have 10, 12, 15, 20, whatever, however many data points you end up getting. I'll say times 10, but I'm not going to say 10 is the number that you have to have. You get what you get, okay? But it should be more than 3. If it's only 3, you need to repeat the experiment. Now, the one thing I'll say is that if you put too much mass here and not enough mass here, okay, if mass 1 is too big in relation to mass 2, then it's going to accelerate very, very quickly. And if it accelerates very, very quickly, you're not going to get nearly as much data. Does that make sense? So what you probably want is to accelerate a little bit slower. So you're going to want to make mass 2 a little bit bigger and mass 1 a little bit smaller. You guys know the deal with the AirLink in the SparkView app. You guys know how to collect data with that. The only thing that I'm going to point out with that, again, is to make sure that you're selecting velocity as opposed to position so that you can get that velocity time data as opposed to position time data. Make sense? All right. You're going to export that data once you've got it done to your Google Drive. And if you forget how to do that, you can just call me over and I'll give you a hand with that. But just a quick little reminder, or a quick little heads up, I should say, because you're going to actually do 2 trials, this is trial number 1, because you're going to do 2 trials and export data twice, then what I'm going to suggest you do is when you, when you export it to your Google Drive, you make sure you know where you put it in your folder, and B, make sure you rename it. So name it according to the date. It's November the 1st, trial 1. And then your second trial will be November the 1st, trial 2, or something like that so that you can distinguish between the two. It's critical, okay, it's critical that you understand and you know which data goes with which trial. Because in the second trial, which is going to be the same thing, the second trial, though, you're going to use different masses. Okay, if I use different masses but get the data switched up for velocity and time, then nothing's going to work out. So make sure you know which is which. All right, once we have all that data for velocity and time in trial 1, what do you think you're going to do? What is it, Megan? Make a graph, plot a graph. And of course, don't forget, you need a title for the graph. And the title for the graph is always y versus x, or y is a function of x. Sometimes Google Sheets does the title for you, and it does it backwards sometimes. So just make sure that you're careful that you fix it if it ends up plotting it backwards for you. Make sure that you label your y-axis, and make sure you put your units in there as well. Make sure you label your x-axis, and make sure you put your units in there as well. whatever they happen to be. Okay, I'm not going to tell you which variable goes on which axis. Okay, you should know, based on what you see in your table here, which variable goes on the x-axis and which variable goes on the y-axis. You're going to plot that graph, and you should get more or less a straight line. What do you do when you get a straight line on a position, on a velocity time graph? Yeah, put a trend line, and the trend line should be it should be a straight line here. Okay, if you're getting data that's not a straight line or close to a straight line, then we got a bit of a problem here. Then you got to, as Megan said, display the equation, and the equation will be in the form of something x 0.74x plus 0.003 or whatever the case may be. This is your slope. That first number is your slope. We don't want that r squared thing. Okay, we want to just simply display the equation on the graph. It's the option that you pick in Google Sheets, display equation, and it should list it like this. So now you got the slope, and that slope is going to represent the acceleration. Now, down here in this little table, you're going to say m1 plus m2, whatever the values of those are. Make sure you show your work in there as well, by the way, guys. Okay, the value of m1 plus m2 times the acceleration that we just found right there. And then over here, you're going to say m1 times g. Think about what was going on there. Okay? If I say m1 plus m2, that's the total mass, right? Total mass times the acceleration. M times a, right? F net equals the sum of the forces. Well, the sum of the forces are simply the force of gravity acting on mass 1. So what we want to do here is see if m times a, the net force, the total mass times the acceleration, is equal to the sum of the forces, the mass 1 times 9.81 meters per second squared. Basically, you're going to answer this question, this analysis question right below, based on that. If those two are equal to each other, then Newton's second law held. If those two aren't equal to each other or aren't close to each other, right, they're not going to be perfect, but if they're not close to each other, then Newton's second law doesn't hold. Now, good news for this. I've created a template for you on Google Classroom for this already. Do not retype all this stuff. Just fill in the template. There's some purple instructions along the way in the template, and it tells you in those purple instructions to delete those instructions. I want you to delete those instructions. I don't want to read that purple stuff again. I wrote it. I don't want to read it again. So delete all that stuff that's in purple. Okay, those are simply there to remind you of what to do. Plot a graph here. Okay, calculate this value here, and so on and so on and so on. And then once you've done that, simply delete it. All right? So you got trial number 1 done? Great. Then do trial number 2. And trial number 2 is going to be exactly the same, except that these two masses will be changed. What do you got to hand in for this? The completed template, which involves data and analysis, and that's it. Basically what you saw up on the board here, although that is kind of a summarized version of it, basically it's what you see, what you've seen up on the board here, times 2. All right? No problem, no procedure, no variables, no conclusion, no sources of error, none of that stuff, just a template that's on there. Just, again, make sure you follow the instructions, whatever's in purple, which includes down here showing our work. Okay, showing our work. So type in the value of m1 plus m2. Shouldn't be, it's not crazy mathematical equations here, so it shouldn't be very difficult to type that stuff in. Okay?